Okay, we are going to solve for theta. Tangent theta minus 3 times the cotangent of theta equals 0. My first step is I want to get rid of this minus sign right here. So I'm going to move this guy over to this side. And I do that by adding. So tangent of theta is equal to 3 times the cotangent of theta. Now I'm going to reduce to sines and cosines. Tangent is sine over cosine, so that's the sine of theta divided by the cosine of theta. And that's going to equal 3 times, and the cotangent is just the opposite or flipped. That's going to be the cosine of theta over the sine of theta. So I have two denominators. I have cosine of theta here, sine of theta here. I need to be having no denominators, so because I have an equation here, I can multiply through by sine of theta cosine of theta. Because when I do that, the cosine is going to drop out here, and the sine is going to drop out here. So this becomes the sine squared of theta times the cosine of theta over the cosine of theta is equal to 3 times the cosine squared of theta times the sine of theta over the sine of theta. And as I said, these guys are going to cancel. Cancel, 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 cancel. So I'm left with the sine squared of theta is equal to 3 times the cosine squared of theta. So now I'm going to change this to 1 minus the sine squared of theta, using that Pythagorean identity. When I do that, I get the sine squared of theta is equal to 3 times 1 minus the sine squared of theta, which equals 3 minus 3 times the sine squared of theta. Let me make sure that I'm not getting extra messages while I'm trying to do this. So bringing everything over to one side, I'm going to add 3 sine squared of theta, add 3 sine squared of theta, and I'm going to write down 4 times the sine squared of theta is equal to 3. Remember that because I have to now erase my board. 4 times the sine squared theta is equal to 3. Four sine squared theta equals 3. That means that the sine squared of theta is equal to 3/4. That means that the sine of theta, taking the square root of both sides, is equal to plus or minus the square root of 3 over 2. So I'm going to have two cases here. One is the positive square root of 3 over 2 case. When I do my unit circle, when the sine of theta is equal to the square root of 3 over 2, That is this guy right here. Square root of 3 over 2, 60 degrees. But I also have my sine of theta is also equal to the square root of 2 when the angle is 120 degrees. So I have 60 degrees and 120 degrees. I'm going to check and see which ones work for that. But also in the meantime, I'm going to go to the negative square root of 3 over 2. This guy right here. I'm going to do negative square root of 3 over 2. Check my unit circle. Where is my sign negative? Well, it's negative right here and right here. And that angle is, of course, I've got 4 pi over 3 there and 5 pi over 3 there. Or that would be 240 degrees and 300 degrees. So let's see which ones work. Remember, my original equation was tangent of theta minus 3 times the cotangent of theta is equal to 0. Well, here, on this one here, let's do a red one. On this one, my tangent is square root 3 over 2, and my opposite is 1/2 divided by 1/2, and I get that my tangent is square root of 3. So if my tangent is square root 3, then minus 3 times the cotangent, which is 1 over the square root of 3. They're always the reciprocal. And if you look, square root of 3 minus this whole thing here is square root of 3, so I have 0, and that works. That does not work for this guy here because now my cosine is negative. Let's do a different color. I'm checking this one right here now. My tangent there is square root 3 over 2 over negative 1/2. Well, no, it still works because this then would become, I'm running out of room. This becomes square root 3 negative minus a negative, and there's a 3 there, 1 over the square root of 3, and that does equal 0. So both of these work. This one works, and this one works. When I go to this one over here, 240, my tangent is positive, my cotangent is positive. This one's going to work as well. Over here, my tangent is negative, my cotangent is negative, but I've got the minus sign right there. That's going to fix it. So all 4 of these are solutions to this problem. Just again, the original problem was this guy right here. Tangent theta minus 3 times the cotangent of theta equals 0. And I have 4 answers. This one, this one, this one, and this one. If I do it in radian measure, it's pi thirds, 2 pi over 3, 4 pi over 3, and 5 pi over 3.